under frequency response and random analysis. Today's presentation is not going to be much longer. It's going to be a little bit shorter than usual presentation. Let's talk about the history of ply stress recovery. Composite ply stresses are available for a long time in a static analysis. However, it was not available for frequency response and the random analysis. And it is because of the difficulties involved dealing with the complex forces and moments acting on a section. What happened during the frequency response is because of the damping, the forces and moments and each and every variable could be out of phase, or have a different phasing angle. MSC Nastran is the first one to introduce composite ply stress recovery for frequency and random response. Now there may be, but as far as I know, that MSC Nastran is the first one. And now let's look at how it was done before. Based on the PComp input, we know the ply locations, we know the ply orientation, we know the properties of each ply, the material property. One can calculate the equivalent membrane and bending stiffness. Once you know the membrane and bending stiffness, you have equivalent properties. Nastran will convert that equivalent to P-shell and solve the problem and perform finite time analysis and calculate the total forces and moment acting on a section. Apply those forces and moment, or we call it stress resultant, and calculate the individual ply stresses. This approach is well suited for static and transient analysis. The reason transient analysis is also well suited is because the output from static and transient analysis are similar. They are there is no phasing, or it is every time step you will have one misses, super stresses. They are both identical in terms of output. However, it's not computationally very efficient with the complex force and moment, and there is no shortcut available.